Hi, welcome back. In the previous lesson, we have implemented EQS for AI to find the proper location to move. In this lesson, we are going to fix animation blueprint for player character, adjust attack distance for AI. Before we get into the video, I want to briefly tell you about my new released courses on Udemy. If you want to create a 2D top-down vampire-like game in Unreal Engine 5, this course is for you. In this course, you will learn pooling system to handle large number of actors, random skills, shop system with save and load framework. We will create entire leveling up system with pickable items, 2 unique bosses and 20 more mobs during the gameplay. Moreover, if you want to learn action game on mobile device, check my action game tutorial course. Your own Sekiro-like basic combat mechanism from scratch by using Unreal Engine 5. Since players' mobile specifications are quite different, mobile game developers do need to optimize lots of assets and logics, including lighting, mesh polygons, textures, tick events, etc. You can play demo right now on Google Play without ads. The link will be in the description below. Or you can head over to my Discord to check latest coupon for the courses. Open EQS AI position file. Select this node. In the details panel, the default value for grid half size is 1000. This value also represents attack distance of AI. So we want to adjust its value in behavior tree of AI, not in EQS separately. How can we do it? Expand this option. In the data binding, select query params. 1000 value disappears. Instead, we can tweak some options in this query params file. The default name is simple grid point grid size. It is a bit long for us, so I delete the prefix, only reserve grid size params. In the behavior tree, we can adjust grid half size by calling this string grid size in EQS. Let's do it. Open behavior tree BT and score AI. Select Run EQS query. In the details panel, it seems that EQS doesn't refresh properly. So clear current EQS AI position and select it again. We can see we can expand query config now. There are 4 members in index 0. Param name is grid size. Great. Behavior tree read this param properly. The default value is 1000. However, we want to store this value in Blackboard variable for us to tweak. We don't have a proper value in Blackboard. Let's create it. Open bb underscore AI. Create a new key. It is a float type. Name it to attack distance. Switch to behavior tree. Click bb key again. Select attack distance. Since we are able to preset value for attack distance to tweak this grid size value, we don't need a default value, so specify it to 0. Save the change. Create a new behavior tree service. Click BT service blueprint base. Rename it to BTS underscore set ATK distance. ATK represents attack. Open this service. In the left top corner, click Override. Choose Receive Activation AI. When this service is initialized, this event will be triggered. Create a new variable called attack distance. Change its type to float. Next, create another variable for Blackboard key. Name it to ATKBB. Change its type to Blackboard key. Drag it to event graph and check instance editable. We are going to modify its value in the behavior tree, which means tweak its value outside current service file. From this Blackboard key variable, call set Blackboard value as float. We are going to pass attack distance value to its Blackboard key. So drag attack distance, Hook it up. Switch to Behavior Tree. Right-click Sequence Node. In the option of Add Service, select BTS Set ATK Distance. Don't forget to check Instance Editable and Expose on Spawn for attack distance float type variable. However, it seems that this service file didn't refresh instantly, so we have to check Expose on Spawn for ATK BB. Compile and save. Back to Behavior Tree. Select this service. In the Details panel, choose Attack Distance for ATK BB. Let's tweak attack distance to 500. Test it in the editor mode. It looks good. Let's try different values. For example, set attack distance to 2000. AI will go to the location where is far from player. That is how we can control attack distance between AI and player. AI will try to keep target distance among these reachable locations. OK, next, let's fix animation blueprint for player. Open Face Anim Blueprint. As we fixed for AI animation blueprint, we don't need such complicated logics. Break ground location state machine. Drag blend space face directly into animation graph. Compile and save. Switch to Event Graph of Animation Blueprint. Duplicate Try Get Pawn Owner. After we get speed value, call Calculate Direction node. Get current control rotation of owner. So call Get Control Rotation from this node. Connect Get Current Velocity with Velocity pin. Set direction value after speed value. Hook them up. Compile and save. We can change camera location now. Select Camera Boom. Reset Socket Offset in Details panel. Set Z value to 0. Adjust AI animation blueprint to make sure its upper body is blending with the whole body. Since we already fixed player character animation blueprint, we can copy most of nodes from it. Let's open ABP AI. Break this blend space. Drag these nodes at the beginning of animation blueprint. Connect it with ground locomotion cache. Switch to Event Graph. Let's copy logics from player character animation blueprint. Select these nodes, copy them. Back to ABP AI. Delete these tick nodes. Copy them here. Then switch to Anim Graph. We do need some adjustments. Break output pose. After layered blend per bone node, connect it directly. OK, almost finished. In the level, delete these obstacles. We don't need these obstacles. OK, let's try it. AI can run as before. However, sometimes AI might stuck at some point. That's because it cannot find a proper location where it's 2000 cm from player character. So let's decrease attack distance from 2000 to 1000 in behavior tree. Delete all these obstacles. Create a wall here. If we are hiding behind the wall, AI will stop moving because it loses sight of player character. There is another bug. When player character is detected by AI again, AI won't move. We can see the error message here. Selected item failed the test. That's because the best value is below minimum value set to 400 with a score -1. Let's fix it. Open EQS AI position. Select distance to query the third condition. We create this condition to avoid AI is standing at the same location, but it couldn't find a proper location in the previous case. So we can decrease this value to 100. Also decrease value for the false condition to 100. Save all changes. When player character appears again, AI starts to move. It can find the proper location according to our preset conditions now. That's great. Save all changes. So next problem is how we can instruct AI to play proper attack animation between blueprint and behavior tree. In this series, I use blueprint interface. Blueprint interface is a kind of file which is designed to communicate between blueprints. Create a new folder in AI folder called BPI, abbreviation for Blueprint Interface. Right-click, select Blueprint Interface under Blueprint tab. Rename it to BPI_combat. Create a first interface function. Rename it to int_get ATK montage time. Create a new argument for return node. It is a float type. Name this return value to time. AI will get current attack montage duration time through this interface function. Open BPAI. Select class settings in the blueprint. In the details panel, implement this interface by click Add button. Search BPI combat. When this interface file is implemented successfully, we can expand interface category in the left bottom corner. Double-click this int_get_ATK montage time function. We can implement logics in this function. Call play anim montage node. Animation montage is a kind of special animation file comparing to traditional animation sequence. We use this node to override current animation temporarily, so we can see AI can play animation attack when AI is idling or running. In the anim montage section, select preset animation montage, primary attack A medium montage. Connect return value of this montage with return node argument time. OK, let's open this animation montage. It looks gorgeous. Great. Switch to behavior tree AI. Create a new task for attack behavior. Create this task in the folder EQS. Rename it to BTT_attack stationary. I add stationary word because when AI is casting magical balls, it will stand still at current location. Open it. Click Override. Call preset event. Receive execute AI, which equals to begin play event. From controlled pawn pin. Call interface function. int_get_ATK montage time. Next, call delay node. We don't want this task is finished during AI is playing this attack montage, so we use this delay node. After current animation is over, we can set current task to finish. Call finish execute, hook it up and check success. Compile, save and close. Back to behavior tree. We use this task after move to task. Drag the arrow. Call BTT attack stationary. After attacking, I change this wait time to 0.2 seconds. Random deviation is 0.1 second. Save the change. Open this attack animation. around 0.28 seconds, create a new notify. Name it to an_attack. OK, we specified attack timing explicitly. This animation notify can be called in animation blueprint. So open ABP_AI in the event graph, call an_attack. Then we cast getPawnOwner to BPAI. Through this casting, any public functions or variables can be referred to. We haven't created any magical balls yet, so we will create it in BPAI in the next lesson. If this video is helpful to you, please consider to support my course in Udemy. See you in the next lesson.